Hi guys, this is Alistair Kroll. Welcome to the O'Reilly Strata Online Conference. This is the second of these online events that we've been running, and I'm really excited with the lineup we have today. We have a phenomenal look at how big data is impacting the startup space. Big data is a huge disruptor, and it's nowhere more important than in the field of new companies that are starting to figure out how to use that stuff. So my name is Alistair. I'm going to be moderating some of the conversations here today and welcoming a variety of speakers from the startup and investor world. The real theme is to look at startup and disruption. Briefly, if you look at the, first of all, some housekeeping stuff. If you're on Twitter, #StrataConf is the hashtag we're using. If you want to yell at me when I'm not trying to pay attention to our presenters and moderate questions, you can find me at @akroll. And we do have a brief break in the middle for some coffee or a bio break, during which we'll be asking you a few survey questions that we'd love to hear back from you on. Before we get started with our first speaker, a couple of thoughts about big data. For a long time, there has been a barrier to entry that many companies have relied on to stop new incumbents entering a market. That barrier has been the significant amount of computing required to process large amounts of data and glean useful insights within that data. And so a lot of companies had invested heavily in infrastructure that they saw as a barrier to entry. That barrier is now dropping because trends like cloud computing, crowdsourcing, collaboration, and so on have made it much, much easier to get access to rich data and to process data and find insights within it. And much as a castle wall was relevant until the advent of gunpowder, so the heavy investment in infrastructure rather than investment in data itself is something that many big companies had seen as a reliable barrier to entry that's now being torn down. And so there are companies disrupting all kinds of industries using this technology, and many of the startups that are eclipsing yesterday's incumbents are using on-demand computing and big data tools to take advantage of that. When we talk about big data, we don't just mean crunching data you own on your own, but this concept of data exhaust, that data is almost a byproduct of our daily lives. We leave a breadcrumb of check-ins and likes and friends wherever we go. Recently I was checking into a hotel, and they actually offered me additional reward points if I would check in on Foursquare and link my Foursquare check-in to the hotel's private membership loyalty program. That's a pretty interesting observation, because if you understand databases, you realize that what they're doing is trying to find a key that will link my online persona and their back-end information so they can market to me better and so on. So there's a lot of money to be made, not just on big data, but simply drinking the exhaust of other people's data as they go about their lives. And this is a tremendous amount of disruption, because you can find insights that the people who own the data in the first place might not have access to. Now, data also has its own gravity. This very important concept, first put forth based on some research that Jim Gray at Microsoft had done, suggests that compared to the cost of moving bytes around, everything else is free. Jim is the guy famous for coining the term, "Don't underestimate the bandwidth of a station wagon full of hard drives driving down the highway." And I think it's fair to say that because of the huge amount of data that we're dealing with across public and private data sets, we're going to see what Dave McCrory at VMware often refers to as data gravity. This idea that data likes to live together, and once it lives together, there is an ecosystem of tools around which that data can be chewed on. Many of today's startups invest heavily in cloud computing technologies, or rather don't invest in them. They pay as they go, they are free to experiment, and they have access to powerful tools for chewing on big data to try and find unusual angles or interesting insights other people don't have access to. And clearly, there's a lot of money to be made in big data. We have all heard about LinkedIn's incredibly highly priced IPO, and whether you think this is a sign of a second bubble or a sign of a new breed of companies, $10 billion is a lot of money for knowing how people are connected to one another. And what LinkedIn is at its core is a big data set, very well curated by a lot of people who are highly engaged to it. So clearly there's a lot of money to be made in this stuff. More and more often, VCs and investors are interested in your big data strategy, where a few years ago they said, what was your outsourcing strategy? And then they said, what's your cloud strategy? Today they're saying, what is your big data strategy? And I think that's something very important for every startup, whether aspiring or growing or looking for an exit, to consider. We've got a great agenda today. I'm thrilled at the caliber of people who've agreed to spend some time talking with you about this topic. We're going to start out with Michael Driscoll from Metamarkets talking about building data startups. We have Dave Schwab from Sierra Ventures, who's assembled a really top-tier panel of investors and successfully exited big players and deep thinkers in technology, talking about how to turn bits into dollars, yens, and euros and give us an insight into what VCs are looking for. We have a brief break during which we'll ask you some questions and share those results. We have two looks under the covers at how some of the giants of big data are using their analytical infrastructure today, both Justin Moore from Foursquare and Daniel McCaffrey from Zynga. And then we have a bit of time for Q&A, which we'll use the online chat room for. And then Janesh Varya is going to talk to us about cloud big data platforms. Janesh is an evangelist for Amazon Web Services, but he's going to put on a nonpartisan hat, and while he will use some Amazon examples, the things he's going to talk about are applicable to most big data platforms. So it's a great lineup. I can't wait to get started on it, and I'm going to ask our first speaker, Michael Driscoll, to go ahead and talk to us about building data startups.
Great. Thank you, Alistair, for that great introduction. And I think as I listen to you, I think it's very clear that there's a lot of commonality here in some of the themes we'll be bringing out. So I want to start today and really talk about two things. First, I want to talk a bit about the opportunity for data startups and some of the forces that are behind that opportunity. And then secondly, I want to talk a bit about the big data stack and how to compete within it. As Alistair mentioned, Jim Gray is known for talking about data gravity. And I think there's an analogy here to be made that building a data startup is a bit like sumo wrestling. Data is heavy, it has weight, and we need agile strategies to succeed. So in a nutshell, my thesis today is that to succeed, a data startup must be fast, big, and focused. And let me start by talking about the big data opportunity. So it's a cliche by now, but in the last decade, we've witnessed this explosion in the volume and velocity of data. There is a mountain of data in this world. And understanding what some of the tectonic forces that are driving this growth in data is critical to success for aspiring data startups. And the way that I like to frame what some of these tectonic forces are, I like to call it the attack of the exponentials. So VCs love curves like these when you put them up. Typically, you would like the curves on the sort of lower left to be cost curves, and the curve on the upper right to be your customer acquisition curve. But and that's true in this case to a point. In the last few decades, the cost of storage, CPU, and bandwidth has been exponentially dropping, while the amount of network nodes or network access has shot up. In 1980, a terabyte of storage cost $14 million. Today, it's $47. So these exponential economics, together with other forces, are really driving this massive increase in volume and velocity of data. Two other forces I think are worth mentioning here, and Alistair referenced these as well. One certainly is cloud computing. Cloud computing has democratized and made computing power and storage a utility. Even as someone quipped a couple of weeks ago, even if it turns out that the cloud is actually just someplace in Virginia, it still provides an easy way for data startups to access compute power. And the second piece is sensor networks. These are the phones, GPS devices, laptops, the instrumented spines, what Bruce Sperling, the sci-fi writer, would call, that are streaming data into the cloud. So even though these forces have fundamentally shifted the landscape. The laws of economics have not changed. And the fundamental rule of thumb for any data startup or any data enterprise is that data value must exceed data cost. If we are going to invest in doing some type of data work, we need to be assured value exceeds cost. And this graph here shows the upper left side is an example of data sets whose cost of collection, storage, and compute exceed their cost, or the value of them exceed their cost. The one at the top there is the human genome. In 2000, it cost $3 billion to sequence the human genome. But something's happening as these exponential economics play out. We see that the tide is shifting, and there's a compression on that x-axis. New classes of data are being revealed as being valuable. The dog genome, for instance, even though it says just dog, but 5 years later, the dog genome was sequenced. And it was sequenced because it was worth doing that. It cost $30 million in 2005. And likewise, there are many other classes of data which now satisfy this rule of economics. Their value exceeds cost. And I encourage all of you to think of a data source that was previously not kept around or not worth collecting, and mull the possibilities for where there may be value to be extracted. So with that, I'd like to now talk about some strategies for success in the data space. In particular, I'm going to outline what the big data stack looks like and talk about some of the competitive vectors within that stack. So the way I frame the large data space is at the bottom we have this persistence layer. This is where you've got HDFS, Hadoop, you've got relational databases, you've got NoSQL. In the middle we have, and by the way, this bottom layer is, I think, of the brawn. In the middle layer we have analytics. This is the intelligence layer. And at the top are services. This is what you do with the brains and the brawn. And as I said at the beginning of my talk, my thesis is that for a big data startup to succeed, you must be fast with your data, big in terms of your analytics, and focused in terms of your services. And let's take each of these one at a time. I'll pull each of these layers out and examine some of the competitive axes that are involved there. And as you'll notice, I'll continue with my sumo wrestling theme throughout. So I hope people enjoy some of these slides. So first, what do I mean when I say that it's valuable to be fast in terms of our working with data? Well, if we take a look at this data layer, there's really a couple of axes that are driving the competitive movements at this level. Those axes are scale first and speed. And if we look at scale, I think it's fair to say that the scale issue has been solved for working with data. Hadoop has won that battle. And I think instead, the place in which many startups are looking to improve is in terms of speed. So if you look at the commercial offerings that are in this space, if you look at MapR, if you look at Greenplum, what many of these companies are doing is they are increasing the speed at which we can access large-scale data. And on that axis, you really see this general shift from batch processing, which is Hadoop, going closer to lower latencies and more real-time access. And one way that this can actually be achieved is through the use of memory. So a couple of days ago, Kurt Monash said that traditional databases will eventually wind up in RAM. I think that one of the solutions to this challenge of data having gravity and the fact that I/O is not keeping up with data scale is memory databases. They offer a dramatically faster access, and prices are dropping more quickly than even disk. So this is in contrast, this emphasis on speed is actually in contrast to the next layer of the stack, analytics, where it's not speed that really defines the ability for a big data startup to succeed as much as scale. At the analytics layer, if we pull that layer out and take a look in the data stack, we see that the challenge is really around scaling out analytics. If you look at some of the players in the space, certainly it's a less mature part of the stack. There are not as many companies that are actively and directly focused on analytics as there are focused on data persistence and data provisioning. But because data is heavy and analytics algorithms are light, there's a big push to think about how to move algorithms closer to the data, to productionize them and get them into production. If you look at many companies that are succeeding, they don't have any generic offering here. Companies like Google have their own custom distributed scalable statistical learning methodologies. And why does this matter so much? Why is it important to be able to be big on analytics? It really comes down to a quote that's been widely stated around the web, that more data usually beats better algorithms. The ways in which predictive analytics drive value, the promise of analytics is that, and I've got a pipeline here, we start with observational data, we extract some features, we learn models of a system, and we use these models to predict on the right side there future observations. And what are some examples of this? I know later today we'll hear from Justin at Foursquare. Foursquare's Explore feature is a great example of predictive analytics, predicting and recommending places you may want to visit. Traffic prediction. If any of us have used Android's traffic program, that's ultimately a result of predictive analytics. And in all of these cases, more data beats better algorithms. And the challenge is to scale out these methodologies. And one result of that is that online learning methods become more important. When I say online, I mean continuous learning over streams of data. And that's important because they scale. And finally, let's take a look at the very top of the stack, services. And the key competitive advantage there is focus. Data startups need to focus on a particular vertical to be successful. It is very hard to be all things to all people or a one-size-fits-all solution. So to dig in here and take a look, this is a very simplified view of what it looks like to be a focused service on the stack. But to give an example, I think what we've seen recently is that there's a number of examples of companies who are focusing on a particular vertical to deliver data services. For example, BillGuard is focused on detecting charges in people's credit card data. Flipboard, News.me, and Woven are all focused on content relevance. And you can imagine a transition is occurring where many of these big data startups with a vertical focus are, as Alistair said earlier, they're not investing in the lower data layer. For instance, Netflix just moved from managing its own data to hosting everything on Amazon. And I think as this data stack matures, what we'll see is companies increasingly not worrying about their data needs, but actually continuing to focus on predictive analytics. But most of all, focusing on serving a particular vertical need. And I guess to take a look at this competitive matrix, let's see if I can push this to this particular slide. success on the big data stack, to put it together, is about being fast, big, and focused. And while on the data layer, one can be competitive by offering some type of generic fast data solution, when it comes to services, it's about being vertically focused. And I think that the opportunities for big data startups is either to be horizontal at that low layer of fast data or to be focused at that top layer of services. I do not believe at this stage that there is a lot of opportunity for companies to be generically focused on analytics. Typically, you will see either a horizontally focused or horizontally offering data company pushing into the analytics, or a vertically focused services company pushing down into analytics. But I don't see that actually being analytics by itself being a place where startups will get a lot of traction. So that's really all I've got to say today about, let's see if I can push this last one, about strategies in the big data space. I'm happy to take some questions. I know we've got a few minutes here that Alistair had put aside for taking audience questions.
All right, thanks, Michael. Great overview. I love the Battle of Exponents stuff. I like the way you said that we've won the scale problem with Hadoop. That's a done deal. I noticed you didn't talk a lot about the interpretation of that stuff. So you mentioned a little bit about the services. How do you think this stuff gets into the eyes of people who can use it to make business decisions who maybe aren't statisticians? Talk to me about the vulgarization of this stuff.
So with regard to at the data layer, or in terms of analytics?
Yeah, I mean, obviously this stuff is going to be most useful when it's available to many people in an understandable way. Where do you think the practitioners and communicators get involved with the data stack?
Oh, sure. Okay, absolutely. Well, my feeling is that I don't think that there's going to be. I think that there's a false belief that there will be this generic methods for surfacing data. I think that the practitioners, the most successful data scientists that are within organizations are going to be individuals who have domain expertise, who really spend the time to get to know a particular vertical. And certainly there are tools out there that can help surface some of the insights, but I don't think there's sort of one tool that works. I think for some folks it will be creating a web application that surfaces insights. For others, it will be internally using tools like Tableau to build visualization reports and drive insights. For others, it may not be actually anything visual at all. It'll be building a fraud detection algorithm, let's say at Square. I know they're building a team to really help identify fraudulent charges. And that may not take the form of anything other than a 0 or 1 that's passed along with each transaction. So I think there's a lot of different ways that practitioners can operate on the stack, but I just don't think that there's not really going to be a one-size-fits-all tool that will facilitate that.
All right. We got a question here from Ben. What about using models to understand a process, not so much for prediction of the future, but for understanding the current state of a process, how it works, which things are important?
Sure. I think that predictive analytics need not be always about looking forward, but ultimately, there's got to be an emphasis on decision making in data analysis. So there's really two kinds. Often in science, people talk about two kinds of science. There's exploratory and there's hypothesis-driven. And I think what that question gets to is there value in exploratory data science, where you simply just take the data and try to get a sense of what's going on? I think there is, but I think ultimately, once you have a sense of what's happening with your data, you need to shift towards having hypotheses about what may or may not happen in the future.
Okay. I thought there was an interesting attempt to restate some of what you were saying, that analytics is by Peter, who's on the chat. Analytics is a feature, not a business, but data scale and vertical services could be businesses. Would you say that's a fair characterization of your point?
Yes, I would say that.
So analytics is just a feature.
I think that, I think it's just the sort of the structure of the marketplace. I think we can look at the financial space as a great example of a mature data vertical, and I think what you'll see there is that there's no such thing as a company who is just driven by some analytical magic secret sauce. I think it's about having a focus in terms of a particular set of trading strategies, or ultimately there are a set of companies that service horizontally the financial space, like KDB is one of the companies I referenced there, folks who provide infrastructure. So I think analytics is kind of this no man's land in the middle of that stack that ultimately, like our listener said, is a feature.
Analytics is a no man's land in the middle of the stack. I think that may get quoted sometime. What about, Sean has a question, what about generic tools that are built to allow a custom dashboard, et cetera, based on those services? Is a generic tool built to allowing people to build custom dashboards a fourth layer to your tower?
So again, I think there's a lot of different ways in which this data can get surfaced, but sure, I think they're important. They're part of it. Initially when I developed this deck, I actually put services and applications at the top. But in general, I find that a lot of folks in the BI space have worked very hard for a long time to create these sort of cookie cutter modules for surfacing data, and I think that we've found, or at least in my experience, that doesn't quite work. And by way of example, so ProtoViz is a great tool for doing data visualization. But if you listen to the folks who developed ProtoViz out of Jeff Heer's group at Stanford, they'll say that their motivation was to break away from this notion of chart typologies, where you would take some data and you pour it into some cast, and then out comes the result. I think that has a more generic, there's a more generic idea there, which is you can't just have BI tools or visualization tools that you pour data into and great things come out. I think ultimately, at this stage of maturity of the data stack, people have got to be focused on a particular, have a little more domain focus for what those surface views look like.
Yeah, and I think the interesting question that you raise here is with this stack of technologies, we really spend a lot of time wondering how to be more interesting than just generic, because generic stuff is not that fascinating, and the generic tools don't give an individual company competitive advantage. I remember at Strata in February we had Creve Maples talk about it took them 3 months to build a system that would visualize 20 dimensions of data related to Formula One race cars going on a racetrack. And it took them 3 months to build the model and make this sort of immersive environment that had sound and lights and 3D goggles and all the science fiction stuff. But once he built the thing, they found the optimal setting for the tires in 5 minutes. So right. He couldn't use some off-the-shelf tool for that. It took 3 months to build it, but once it was built, he could find the perfect setting for the tires in 5 minutes. And that underscores the idea that generic analytics give you generic answers that don't give you a sustainable competitive advantage for a particular vertical. Right.
And I think to that point, one of the most important parts of any type of analytical process is what's sometimes called feature engineering. It's not about just the data and the tool. It's about the domain expert who understands what that data is, what some of the artifacts in it are, and can choose the features that, if looked at, will drive the solution. In physics, it's often said that the framing of the problem is most of the effort. And I think the same goes for analytics as well.
The framing of the problem is most of the effort. Good line. Okay, thank you very much, Mike. That was a great conversation, and I know there's people on in the chat room, the group chat, who are also asking lots of questions. That's all we have time for you right now, although Mike is available on Twitter. He'll probably hate me for inviting you all to bug him there. It's M.E. Driscoll.